All right, we have a compound that's 64.9% carbon, 13.5% hydrogen, and 21.6% oxygen, and has a molecular mass of 74 grams per mole. Okay, so that is for the molecular formula. Okay, so the first thing we're going to do is we are going to find the empirical formula. So we're going to rewrite this, 64.9% carbon, that's C. Let me leave a gap here. 13.5% hydrogen, H. And 21.6% oxygen, or O. Step 1, convert to 100 grams. Okay, which means I'm just going to take that percent and rewrite it. 64.9 grams. 13.5 grams, 21.6 grams. Convert to moles. Step 2. 64.9 grams of carbon, and there's 12.01 grams in 1 mole. There's 1.01 grams in 1 mole of hydrogen, and there's 16.00 grams in 1 mole of oxygen. If you looked at the mole map, it would have told you to go from grams to moles. You divide by the molar mass. So hopefully that's getting to be quite commonplace at this point. So now we're converting to moles. 64.9 divided by 12.01. So 5.40 moles. 13.5 divided by 1.01. 13.37 moles. 21.6 divided by 16.00. 1.35 moles. And now we look at all these and we divide by the least. So that's 1.35 moles. We keep those units in there so we can divide and get rid of those units. .35 divided by 1.35 is obviously 1. 13.37 divided by 1.35 is 9.90, so round that to 10. 5.40 divided by 1.35 gives us 4. And now we're going to rewrite C4H10O1. C4H10O1. And that is it in simplest form. So that has to be its empirical formula. Now to find the molecular formula, we first need the molar mass of the empirical formula. That's 4 times 12.01 plus 10 times 1.01 plus 1 times 16.00 gives us a molecular formula of 74.05. So that is the empirical mass of C4, so 4 times 12.01 plus 10 times 1.01 plus 1 times 16.00, and all those numbers can be found on the periodic table. Okay. And now the grams per mole that we have is also 74 grams per mole. So when we divide those two, and we get to that nearest whole number, our multiplier is going to be 1. So in this case, our empirical and our molecular formulas are the same.